Hey everyone, welcome back to my channel. This is Rahul. Today we are tackling an exciting problem called XOR All Numbers. This problem is not only fun but also a great exercise for your understanding bitwise operations and efficient coding techniques. By the end of this video, you will learn how to solve this problem step by step and understand every line of the code. Let's get started. Here the problem goes like this. We have two arrays nums1 and nums2 which contain non-negative integers. There is another hypothetical array num3 that contains the XOR of all pairings of integers between num1 and num2. For example, if num1 have two numbers a and b and num2 have cd, then num3 would be like this. A raised to, sorry, I will just give the example here. If nums1 equal to a and b, then nums2 equal to c and d, then num3 will be like a raised to c, a raised to d, b raised to c, b raised to d. Like that, we have to take. Our task is to compute the XOR of all elements in num3 without actually constructing it. Like that, we have to do. So, if you take this example 213 10250, you can see how all they write this. So, let's see how we can solve this efficiently. Instead of explicitly creating num3, we need to think logically. First of all, each number in nums1 contributes to the XOR with every number in nums2. So each element of nums1 is XOR nums2 dot length times. Similarly, each number in nums2 is XOR nums1 dot length times. So here is the key insight. If an element is XORed an even number of times, it cancels out. For example, x raised to x equal to 0. If an element is XORed an odd number of times, it contributes to the final XOR. This means we only need to compute the XOR of all elements in nums1 and compute the XOR of all elements in nums2 and use the length of the arrays to determine which contributions matter. Now let's write the Java code for this problem. It's super concise and efficient. Here how it works. First of all, we need to declare variables in order to store the XOR of all elements in nums1 and nums2. Let's name it as XOR nums1. Like that we have to do for nums2. XOR nums2. Then we have to compute XOR of nums1. So we will use one for each loop for int num nums1 XOR nums1 is to equal to num. For nums one, if you take this one 2 1 3, it XOR nums one, it will start with 0, and it will check XOR nums one 0 raised to 2, which will give 2. Then it will go to next 2 raised to 1 3, then again 3 raised to 3 0. Final value XOR nums one will be 0. Then we have to compute for nums 2. Same we have to do. Nums 2. Here also the same. So here what happens is it will first 0, 0 raised to 10, 10. Then second step 10 raised to 2, 8. Then 8 raised to 5, which will give 13. Then 13 raised to 0, 13. So final value of XOR nums 2 will be 13. Then we need to check length of nums 1. If nums 1 dot length mod 2 not equal to 0, result to XOR nums 2. Here the length of nums 1 according to this one I am telling is 3. So we include XOR nums 2 in the result. So the result will be 13 here. Then same we have to do for nums 2 dot length. Result equal to XOR nums 1. So here the length of nums 2 is even, right? 4. So the condition is kept. Now nothing much, we need to return the result. Oh, sorry. What's here? Okay, I forgot to initialize in result. Just int result. So that's it for here. Now I have to initialize it to 0. That's it. Yeah, it's working. So I hope you understand the way I explained using this example. Yeah, it's beats 100%. So the time complexity is big of n plus m, where n is the size of nums 1 and m is the size of nums 2. This is because we traverse both array once. When it comes to space complexity, it is big of 1, since we are only using a few variables for computation. And that's it for today's problem. We solved XOR all numbers step by step and learned how to leverage bitwise operations for efficiency. If you found this video helpful, make sure to give it a thumbs up, subscribe to the channel, and hit the notification bell for more coding tutorials and interview tips. Drop a comment below if you have any questions or suggestions for future topics. Thanks for watching and see you in next video.